Maths of the Coronavirus, Part 3, Rates of Change. You'll hear a lot during the coronavirus about the graphs, that is, flattening the curve or something like that. So let's have a look at some of the graphs you're going to see. Here's one from the ABC website that shows the cumulative count of people who have coronavirus in Australia. And you can see that the number increases all the time. That is, the number of people who have coronavirus goes up. But if I look at this graph from the same website on the same day, it looks like things are getting better. The number of new confirmed cases is going down. One graph keeps increasing and one goes down. What's going on? Well, if you're particularly observant, you might notice that the titles on each of the graphs is different. In the first graph, it says confirmed cases cumulative count, which means it's always going to get bigger until people start getting better, because we're adding on every day the number of people that get the virus. Whereas in this graph, it's only the daily count. So the number of people that are newly diagnosed with the virus each day. Linking the two graphs together is this maths idea called the rate of change. In our last video, we talked about how important it is to slow the spread of the virus. We can't stop it necessarily, but we can slow down how quickly it spreads. And we used logarithms and a logarithmic scale as one way to look at how quickly the virus is spreading. Today, we're going to have a look at a different way to measure how quickly the virus is spreading, and it's called the rate of change, and it's all got to do with gradients. If you've done any linear algebra, you'll remember that gradient is just the maths way of saying how steep is the line. Looking at the line here, we start on the left and we climb up the hill to the right. And we measure our gradient, which for some strange mathematical reason we call m, as how far we went up, that is the change in the y value, which we call rise, divided by how far we went along, that is the change in the x value, known as run. So steepness depends on how far you went up, rise, and how far you went along, run. The bigger the gradient, the steeper the line. Let's have a look at how this idea of gradient relates to the spread of the coronavirus. Over here on the right, I've created some dummy data, and I've used quite small numbers, so it's easy to see. So, at the start, day 0, one person gets the virus, so a total of 1. When we go across to day 1, 2 new people have gotten the virus, so that gives me a total of 3. Going across to day 2, 7 new people get the virus, and that gives me a total of 10, and so on. So let's take this little bit of information here and pop it onto a graph on the left-hand side. You can see down here that at day 0, at the start, 1 person gets the virus. So we start with that red dot. And then we move across to day 1, and now a total of 3 people have the virus, just like over here in the table. Move across to day 2, and now 10 people have the virus. Day 3, it's 22, and so on. Let's have a look then at how this concept of gradient applies. And to make it easy to see, we'll just put in day 0 and day 1. So let's put in the little line that joins the two, and have a look at the gradient of that line. Remember, gradient is start at the left, go to the right. How far did I go up? Divided by how far did I go across? Well, how far I went across is quite easy. I started at day 0, I went to day 1, so I went across 1. In terms of up, well, it was one person sick, then it became 3 people sick. So I've gone up 2. So up 2 across 1. That gives me a gradient of 2. That's how steep the line there is, 2. Put in day 2. I've still gone across 1 day, but this time I've gone from 3 to 10 because 7 new people got sick. So across 1 and up 7. The gradient of this little bit here is 7 over 1, or 7. As we said, the bigger the number, the steeper this is. Go across to day 3. Now we know over here that there 12 new people got sick, so it doesn't surprise us that the gradient of this is 12. Again, across 1 day, up from 10 to 22. So you can see here that as these first few days go on, more people get sick every day, and the gradient of the line for each day is steeper. Let's put in day 4. And you can see it's very steep indeed, because 28 people got the virus on that day. But let's see what happens when we go to day 5. The steepness has started to flatten out a bit. We've gone across 1, up 5, so that's only a gradient of 5. Because only 5 new people got sick that day. So it looks like the curve is starting to flatten a little bit. And then when we go across to day 6, it's flattened even further. Only 2 new people got sick on that day. So we've got a gradient of 2. So you can see the relationship between how steep each little line is and how quickly the virus is spreading. And this steepness is what we call the rate of change. How quickly does something change? In this case, how quickly does the number of people that have coronavirus change? And it's very easy to see it using the steepness of the line on the curve. Now, minor problem. Here's my original curve again, and there's a distinct lack of lines on that curve. Well, don't stress, because we can imagine a line on the curve using a little maths trick called a tangent. And here's a tangent I prepared earlier. So the red curve is very similar to the one we saw for the growth of the coronavirus. And have a look at this little blue line here. It just touches the curve there. Think of the tangent a bit like a skier on a slope. As you move down the slope, you can see the skier change how steep those skis are. And so if you move from one day to the next, you can see the rate of change, the gradient changing as we move. So we started down here and the gradient was very low, which means that the virus is spreading very slowly. As we come across more and more days, the gradient, the rate of change increases, which means the virus is spreading much more quickly. And then as we get up here, we start to see that gradient flattening out again, which means the rate of change is slowing, which means the virus is spreading much more slowly. Use your imagination with this curve. Imagine the skier, the tangent on this curve, and that flat line sliding up the curve. And see if you can see right near the top, right where we're starting to get control, where the rate of change, where the spread of the virus is slowing down. And if you want to explore more about the relationship between straight lines and curves, and you've got some time on your hands because you're isolated in your house because of coronavirus, have a go at doing one of these. You might have done this in primary school. It's called string art. You just take nails in straight lines and join bits of cotton or wool between one and the other, and a whole lot of straight lines all of a sudden becomes a curve. If you feel particularly creative, you can do all sorts of stuff, with straight lines becoming curves using string art. Look it up on Pinterest or YouTube. There's plenty of instructions around. It can be a lot of fun, and it can help you understand this idea of a tangent, the straight line, the curve, and the rate of change. Go out and have a go.